Hello everyone. So today we are gonna study section 2.5, which is how you can see a pedigree and how you can find out what is the dominance and the recessive pattern, or what is the pattern of inheritance rather. So I will just be focusing on that for this lesson, and the other lessons I will be discussing the other part of genetics, okay, because this is a very crucial concept for you to understand. Most of the students, they fail to find out the pattern of inheritance. That's why I'll just be focusing on that in this particular video. Okay, let's look at what do we mean by a pedigree. Okay, a pedigree is basically a pattern of inheritance that runs in the family. Okay, so here the most general thing that you have to know, the first thing that you have to know in this are the symbols. The circles always represent a female and the square represents a male. So when it's a half circle or a half square, it's a carrier. And you know what a carrier for a trait is? A carrier is a person who has the defective allele or the defective gene, but is not showing the trait. Okay, he has just one copy of it. So he has it, but he doesn't have the disease. You can just for simplification purpose, I will explain it like this. Okay, so anything which is half is a carrier for the disease, and anything which is full circle or a full square has that disease or has that trait. Okay, so the first thing you have to know is how do you read a pedigree. There are basically two things you will look for in a pedigree. The first thing you will look for is whether it's a dominant trait or whether it's a recessive trait. Okay, how do you know if it's a dominant trait or not? So for a dominant trait to happen, at least one of the parents must have the traits, and it will not skip a generation. But if it's a recessive trait, there's no need for the parents to be affected, and the recessive trait will skip a generation. Now, before I go, I'll come back to this slide once I finish the dominant and the recessive thing. Now look here first. I do not want to know anything from this information right now. If you look here and you have to figure out whether it's a dominant or a recessive trait, it's actually a bit difficult. Why? Because we just have two generations. So it's very difficult to know if it's a recessive or a dominant trait when you just have two generations. But here you see an autosomal recessive. What recessive? Because it's not skipping a generation. But remember, I said if one of them has the trait, it has to be dominant. But remember, if you have a case in which one of the parents has the disease, but still the disease is not skipping a generation, please mind you that you will give importance to the skipping of generation. In this case, you will not give importance to whether the parents have it or not. You will give importance to the skipping of generation. So we will say it's a recessive disease because it's not skipping a generation. I'll give you more practice on this a little later. Okay, coming to the next concept, whether it's autosomal or an X-linked. This is the second thing you will look for in a pedigree. So if it's an autosomal disease, then both males and females will be equally affected. But if it's an X-linked disease, males will be affected more, or we can say only males will be affected. Okay, let's look at this disease. So here we see that both the males and the females are getting affected. So it has to be an autosomal disease. If you see only the males affected, no females, then make sure you write X-linked disease for that. Okay. Now, the question here is, they have already given you the inheritance pattern. What are they asking you is, if the individual 3 in generation 2 is marrying a normal female who is heterozygous for the trait, what is the possibility to have an affected child? Now, before we solve this, we have to look into certain things. Okay, first of all, we know it's an autosomal recessive disease. And they're asking for individual 3 in generation 2. Means they are first information is about this person. And this person is a male and he is having the disease. Okay, so when if he's having the disease, and it's an autosomal disease, we know, just give some random letters. So if he's having the disease and it's recessive, then he has to have 2 small letters. if it's a recessive disease, we know they have to have two small letters. So this person is, say, small a, because he's having the disease. He gets married to a female who's heterozygous. When you say heterozygous, heterozygous means I have two different letters. So I have a capital A and I have a small a. So he's getting married to somebody who has this genotype. Now they want to know what is the possibility to have an affected child. So when you have figured out your genotype, the first thing that you will do is to make a Punnett square. How do you make a Punnett square? You all know it. I suppose you all know it how to make it. First write the first genotype on the top. Okay. Then you write the second genotype here in the row part. And then you start cross multiplying. So it's capital A, small a, capital A, small a, small a, small a, and small a, small a. Okay. So now they say, now look at this is the genotype for the child, for the offspring. Okay. So these two are heterozygous. So if it's a autosomal recessive, they will not have the disease. We know they have to be having this. So they said an affected child. So they are looking for small a, small a. So how many small a is 2 out of 4. Okay. 2 out of 4 of this thing. And if we can easily see, it is 50% of the child. So out of 4, 2 will be affected, 2 will not be affected. So when it's 2 out of 4, we know the answer has to be 50%. Okay. So this is how you will figure out your answer. So the answer is 50%. Now, in the next diagram, look what they're asking for. In this type, this is easy. They're asking you, like, tell me the inheritance. There's no figuring out anything. So let's look at this first. When you look at this, you see one of the parents are being affected, and you see a skipping of generation. Why do I see a skipping? They're all carriers in generation 1. Look here. In this generation, they are all carriers. Okay, there is nobody affected. So there is a skipping of generation here. And I said when you have a skipping of generation, make sure you write recessive. So we know it's a recessive disease. Let's look out for the other one, which is X-linked or the autosomal. So when you see here, look how many males are affected. 1, 2, 3, 4, 5, 6. 6 males and only 1 female affected. So I told you when they have more males and less female, or only males and no females, then you have to make sure it's an X-linked disease. Why? Because autosomal means both male and female will be equally affected, which is not the case here. So skipping of generation, that means recessive, and males are more affected than females, that means X-linked. So the answer for this question will be the pattern of inheritance is X-linked recessive. Now coming to the next one, they have given you here that it's an autosomal recessive disease again. Now they say if the affected male in generation 2, means they are talking about this person, marries a normal female who is homozygous for the trait, what is the possibility to have an affected child? Okay, now let's figure out with the same concept. We'll figure out with the genotype first. Affected male and autosomal recessive. So it has to be 2 small letters. Okay, now he's marrying a normal female who is homozygous. So because she is normal, she cannot, homozygous can be 2 small a's, 2 big a's. But since she is a normal female, she doesn't have the disease. So I cannot write 2 small a's. I will write 2 big a's for this. And then the same concept, I will make a pedigree and I will start figuring out the genotype. So small a, and big A, and then I'll cross multiply, and then you will see that in all the cases I have the same genotype coming, which is heterozygous form. Okay, all the four children will be heterozygous. So now they say, what is the possibility of having the disease, the affected child? We see there is no affected child. There is no small a, small a. It's a recessive disease. For the child to be affected, it has to have a, small a, which is not the case in any of the four children that we have figured out. So the answer for this question will be 0%. Okay, so the answer is 0% for this. And finally, in the last question, again, they have given you for albinism, which is autosomal recessive disease. Again, it is a disorder in which you see white patches on the skin because there is a problem with the gene that produces melanin pigment. Melanin is a pigment which gives you the skin color. Okay, so these people, they don't have color in their skin, hair, and eyes because they lack the gene which makes this pigment for them. Anyways, so albinism, they say, is a recessive disorder. Now we know for a recessive disorder to happen, this should be with genotype for any person who has the disease. But they say both the parents are carrier. If there is a carrier, they have to have one copy of the defective gene. That means both the parents have this genotype. They are both heterozygous. Okay, if they are carriers, they have to have this genotype because carrier means they need to have one of the defective gene, which is small a. I cannot write big A because they say if it's a carrier has to have one bad gene. So now when you have this, you will do the same thing. You will start making a Punnett square to figure out the genotypes here. So I have a big A, small a here. I have a big A, small a here. And then start cross multiplying and writing your genotype. Okay, this is what we do here. We start doing it. And the last one is small a, small a. So now when you look at all the four genotypes of the children, they are asking you what are chances for their child to be albinos or having the genotype. Okay, so having the disease. So when you look here, what are the chances? Only one of them have it, right? So 1 out of 1, 2, 3, 4. So 1 out of 4 is the chances for a child to have albinism. So what is a 1 out of 4? We know it's 25%, right? So the answer for this question will be 25%. With this, I would like to wind up this particular section. I hope this is clear to you. Please make sure you practice more pedigrees and try to find out the inheritance yourself and try to find out the genotypes. Or every genotype you have to make a Punnett square and figure out the genotype of the children and what is the ratio or what are the chances of having a baby who is having the disease or who is heterozygous or who is not having the disease. With this, I would like to end up this video. Thank you for watching.